Hello, in this video I'm going to demonstrate the implementation of our two proposed new algorithms called the B scheduler and D scheduler. A B scheduler algorithm, the goal of the algorithm is given a budget, we need to first make sure that the execution cost of the workflow is always less than equal to the budget. And at the same time, we would like to minimize the make span of the workflow. Towards this, we have already created a workflow in data view. Let me access data view. So here you can see the workflow has a total of 7 tasks, and there are 3 levels. As you can see, this is a level 1 and a level 2 and a level 3. So we have already created this workflow as a synthetic workflow in data view, which means each one of these tasks does some processing inside the scope of the workflow task at the P workflow level. And then I will first show the implementation of the B scheduler for the workflow created in the data view. The budget that we provide for this workflow is $100. So let's go ahead and run the code. So the code is getting executed. And you could see that I have provided $100 budget, and the total cost of this execution of this workflow is below the budget, and the make span is 88,052 minutes. So that's the best solution that it was our code is able to generate. And Now I would like to compare the algorithm with the existing LP solver tool called CPLEX. It's interesting that I was introduced to this tool by existing research scholar in the conference, and he was using this tool for his work, and his paper was published in the Cloud Research Track. And I googled about this software, and came to know that they are able to generate an optimal feasible solution, which can be a best solution. So there are also other LP solver tools. They call the other tool is called Gurobi, is the other tool that also does the same thing. But CPLEX is an IBM tool, and we already integrated that with the data view, and see the results for the comparison. So our solution, and now first let me run the same workflow with the same budget, $100, using the CPLEX. So when I run it, let's see. Okay, so the workflow got executed successfully, and you could see that it was able to minimize the make span, 86,728. The one that we got was 88,000. So so the comparison that you could see is using our CPLEX, we get 88,000, 86,728, and then using our B scheduler, we are able to get the make span 88,000. So which means that we are very close to this optimal feasible solution that CPLEX generated. So this is a comparison that we are going to use, but also CPLEX does not consider the actual data movement and the provisioning, whereas we consider in B scheduler, we consider all those as well. So that is for the comparison, and in the future, in the next few days, as time permits, we are interested to implement the knapsack, the paper one. We are in the process of doing that. And one of the challenge that I foresee in this paper one is that paper one schedule the bag of tasks in a heterogeneous I am sorry, in a homogeneous level. So the tasks are all like same, they are similar, they are um, homogeneous tasks. So whereas for us, our tasks in the level are heterogeneous, which means they can have different computation time and different outgoing data edges. So this is the thing that we are working on right now to see, if we can do the comparison with the paper one. Um, but if you have any suggestions, please feel free to let us know about it. And the second thing in this video is I'm going to demonstrate the descheduler, which is primarily implemented by MADI. Um, so the goal of descheduler is, given a deadline, we would like to meet the deadline, which means we need to first make sure that the total execution time of the workflow is always less than equal to the given deadline. And at the same time, we want to minimize the execution cost of the workflow. So let's look at the same workflow that we have created here, and then let me run this descheduler to see how the output is generated. So I'm going to comment this line of code here for C scheduler, and I'm sorry, B scheduler, and then let me uncomment this for D scheduler. Okay, and let's go ahead and run this code. So the code is executed successfully, and as you can see, I fixed the deadline as 80,000 in the code. So you can see that the deadline is fixed here for 80,000, and the total cost that it took to execute the workflow is around $119.29. Okay, so that's using our descheduler. It is 119.29. So the same thing we would like to compare with the Cplex software. We would like to compare that and see how they are able to minimize the execution cost. So let's go to Cplex, and now I would comment this line of code here for descheduler and uncomment this. Okay, so let's go ahead and run this. Okay, so there is no optimal solution, it says, because I need to give the deadline as the same as the one that we had for descheduler. So I'm going to give the deadline as 80,000 and then rerun the program. Okay, so now you could see that the Cplex is able to minimize the make span, and the execution cost is $106.44. Again, our descheduler is also very close to this so-called optimally feasible solution. So we are also very close to the Cplex. And again, we would like to use paper one technique and try to address the challenge that we foresee. And then we will try to compare our descheduler work with paper one and the Cplex. So thanks for watching this video.